Alrighty then. How do we take a sample? We need to take a random sample of the population, figure out our problem. So we want to know what class is the favorite class of UNLV students. We'll take a sample of 100 students and they should tell us what their favorite class is. We need it to be random. Random before meant there was a pattern. When we talked about random, when we talked about probability, it just meant that there was a pattern. When we talk about random sample, we have a specific pattern. So if we're going to draw names out of a hat or anything else, we have a random sample. To have a random sample, which is required to use statistics that our sample be random, each element of the population has an equal chance of being chosen. That's what random means here. So if we're going to ask who's going to win the presidential election and we only talk to Republicans, that's not a random sample because each element of the population does not have an equal chance of being chosen. If we only call people who have AT&T phones, that's not a random sample because each element of the population does not have an equal chance of being chosen. If we only conduct our survey in the student union and we pick students who are in the student union, that's not a random sample because each element of the population has an equal chance of being chosen. Many years ago, they did a study to see if we needed a new rec center, wellness center. And they did it in the old wellness center, the old rec center. Well, that's not a random sample. It's not legit because each element of the population did not have an equal chance of being chosen. And likewise, they asked people if we needed a new student union in the old student union. In both cases, the people who were sampled are highly likely to use the facility and therefore more interested probably in getting a new one than the people that they didn't survey. All right, some ways to take a good sample. First is called a simple random sample. You have 10 people, you're going to pick one, you put their names in a hat, swirl them all around, pick one up. Simple random sample. In a simple random sample, you have a list or a hat full of names or something, some list or theoretical list that includes every single possible thing or person that belongs in the population. So you have every student at UNLV or every light bulb that comes down an assembly line or every person who owns a Honda. Then you pick them randomly one at a time. You pick them by a random method, and again, we use computers to do this in the modern world. So Excel can pick randomly for you. But it's one at a time from a list of everything. We very often don't have a list of everything, and it's hard to pick one at a time. So more likely we do something called a cluster sample. In a cluster sample, we randomly select groups of people and survey everybody in the group. So if I want to randomly survey a bunch of students, what I do is take a list of all the classrooms and all the times there are classes and randomly select classrooms at different times of day and night. So I end up with a list of 50 classrooms from 8:30 in the morning till 7 o'clock at night, Monday through Friday, in different buildings all over campus. By selecting the rooms at random, I select the people in them at random. So this is the most common way we do surveys. We pick people by zip code, or we pick people who are, we pick 10 grocery stores at random and we go survey everybody in them. We pick the classrooms at random and we go survey everyone in them. This also means that we're going to sometimes survey people more than once. You might be in 2 of the randomly selected classrooms, in which case you have to fill out the survey twice because you were picked at random. You have to get picked twice. Okay, so cluster sample. Stratified sample is sort of like cluster sample. We divide people up into groups or things up into groups, but we divide them up in groups by something that's related to our topic. Cluster sample, the groups are unrelated to the topic. Stratified sample, the groups are related to the topic. So accountants do this all the time. If you're going to audit a business, you care more about $1 million error than a 5-cent error. If you're going to look at the purchases of the business, or you want to look at the receipts from its customers. You don't care about 10-cent receipts. You care about $1 million receipts. You don't care about 10-cent purchases. You care about $1 million purchases. So very often what accountants do will divide the receipts up into groups. So the, under $1, $1 to $10, $10 to $100, over $100, something like that. That's oversimplified, but you get the idea. And then they'll look at all the ones over $100 and 50% of the ones between $10 and $100 and 10% of the ones between $1 and $10 and 1% of the ones under $1. Stratified sampling is in some ways not really random, but it's very useful, and again, accountants and people like that use it all the time. Systematic sampling is an nth thing. Nth. NTH at the end. That means you stand at the door of the student union, and every 10th person who walks in the room, you survey them. You stand in the corridor of a mall, and every 20th person that walks by, you survey them. You're standing at an assembly line, and you're looking at light bulbs, and you grab every 100th light bulb down the assembly line. In theory, because those light bulbs are people or whatever come to you randomly, then the systematic sample also generates a random sample. Accountants would do this again sometimes too with receipts, where they'll look at every 50th receipt or every 100th receipt, every 1,000th receipt, something like that, and then they get a random sample. My little note down here, it's important that we draw these samples with replacement. And you're saying, So if I'm pulling names out of a hat and surveying people whose name comes out, there's 1,000 people in the hat. The first person has a 1 in 1,000 chance of being chosen. If I don't put that name back in, the next person has a 1 in 999 chance of being chosen. Can't have that. Every element of the population needs to have an equal chance of being chosen, so we want to sample with replacement. We want to put that name back in and take a chance on selecting it again. Again, if we're in a cluster sample and we get 2 surveys, we need to fill them both out because we need to sample with replacement to keep the odds, the probability from changing. Okay? Now, there's some bad ways. Bad way number 1 is what's called a judgment sample. In a judgment sample, we use our judgment to decide who's in the sample. This is bad. Sometimes people try to fancy this up and call it a scientific sample. It's still relying on people's judgment to decide what's scientific. And it's not really a good way to sample, but people do it. Judgment means, I think that person looks like they know something, so I'm going to ask them. Or let's suppose that your job is to accept shipments of fruit. You work at a grocery store and you have to accept the shipments. If you in your mind think that you know where the bad apples are in the box, then you're doing a judgment sample. Okay? Related to that is something called a convenience sample. In a convenience sample, we pick the easiest ones. So you take the top box, open it up, look at the first apple you find, and decide whether to accept the shipment based on that or not. If I know you do that, I'm going to make sure to put the bad apples at the bottom of the box. Again, 2 bad ways to sample. Third bad way to sample is the voluntary response sample. Voluntary response means you go text 32689 if you like, red, and text 6240 if you like blue. Voluntary response. Dial in and leave go to the website and click, and you take the survey. We just had a presidential debate. All of the voluntary response surveys went to one candidate, and all of the random sample surveys went to the other candidate. So one candidate could say they won based on all the voluntary response samples. The other candidate could say they won based on all the random samples. As statisticians, we trust one of those more than we trust the other one. All right, so just a few quick things about surveys. Designing a survey is an art. It's a very difficult thing to do well. You learn by failure a lot. If you want to do it right, you need to take a class. It's a long, hard thing to do, to learn to do this well. It'll take you a semester to learn what you're supposed to do and years to figure out what to actually do. But some things to know, just some wording things. If a question has a set of responses and you have to pick one, that's called a fixed response question. So a question that says, how many dogs live in your house? 0, 1, 2, 3, more than 3. That's a fixed response question. One of the more common kinds of fixed response questions is called a Likert scale. And yes, it's pronounced Likert, not Likert, Likert. So Dr. Likert, who's still alive, by the way, in a Likert scale, you ask someone a question like, I love going to school at UNLV. And then you give them responses like, strongly agree, agree, neutral, disagree, strongly disagree. What the perfect Likert scale question is up for debate. They should always be positive. You need to ask multiple questions, and then they should always be positive. The good answer should always mean the same thing. Strongly agree should always be a positive response, and strongly disagree should always be a negative. So you would never say, I hate UNLV. You would always say, I love UNLV. Positive question. You have to be careful that you don't, for example, put the word and in there and say to people, I like red and blue. And now I can't answer that question. If I like red but I don't like blue, or the other way around, I don't know how to answer that question. If I like one more than the other, I don't know how to answer that question. So we need to make nice, clean questions. They always are positive, and then we add this. There are debates in this. There are people who believe in 5. There are people who believe in 7. So some people think you should do strongly agree, mostly agree, agree, neutral, disagree, mostly disagree, strongly disagree. And then there's the fight over the neutral. Some people don't like putting the neutral word in there. They just want it to be strongly agree, agree, disagree, strongly disagree, and make you choose. Others want that neutral in there. And every time you do a survey, you're going to have a fight with someone. If you like the neutral, there's going to be a non-neutral person running around. And if you don't like neutral, there's going to be a neutral person running around. Okay? The other kind of question is what's called an open-ended question or open response question, and that's, what do you think about UNLV? And then you get to fill in the box. Okay? The problem with surveys, what we get into is many times they have what's called a response bias. There's something about how you ask the question that induces particular answers in the respondent. You use words that inflame, or you write a very vague question that you're going to interpret one way, but other people could interpret differently. Okay? So we need to avoid that and, again, take a class. The other thing is that if we do these face-to-face or over the phone, we get what's called interviewer bias. And what that means is in face-to-face interviews, in face-to-face survey taking, people answering the survey try to answer it the way they think the person who's asking the question wants to answer it. They're much less likely to disagree with you. So all the time you see these people where they take, 5 people and they say, which car company is won the most awards last year? And then the open thing goes, Chevrolet. And everybody goes, wow, I didn't know that. That's amazing. Well, those people have interviewer bias. They know they were brought there by, or probably brought there by Chevrolet people, because Toyota's not going to take them to the thing and then show them a bunch of Chevrolets, unless there's something bad with the Chevrolets. So the response there that you get is interviewer bias. The way we figure out a lot of this stuff is to do a pre-survey, what we call a pilot survey. In a pilot survey, you randomly select a bunch of people, or even not randomly select a bunch of people, and you give them the survey and you see the results. I once had to do a survey of 3rd, 4th, 5th, and 6th graders, and designed what I thought was a beautiful survey. And then I found out things like kids don't want to write down that they're 8 or 9 or 10. Sometimes they want to write down that they're 6.5. Kids are better at circling answers. With adults, you let them check things or write things in or filling. With kids, we figured out that if we really wanted them to do it right, we needed to set things up so they could circle them. So by testing the survey, you avoid problems. If we had surveyed and we ended up surveying, 20,000 kids, if we had just done the survey the way we originally wrote it, we would have had 20,000 bad surveys. But instead, we did a test on 30 kids. In fact, we did twice. We tested it. And by the end, we thought we had a pretty good survey and we got good results. But that's only because we did a pilot and we figured out that some kids think their dog is their sister or brother. And we put in a question on people owning dogs and cats, not because we wanted to know anything about dogs or cats, but we wanted to make sure that kids did not include their dogs and cats in the count of siblings. So there's two kinds of errors that occur in sampling. One is called a sampling error. Sampling error is not a problem. We know from all our other statistics that we've talked about so far that there's this normal error that occurs in things. You throw a dart at the dartboard, it doesn't always land in the same place. If we do a sample, if we randomly select 10 people to try to figure out what the average height of the average UNLV student is, occasionally we're going to get a basketball player. And occasionally, the average height of UNLV students is going to be 6'3". That's just sampling error. There's nothing wrong with that. Perfectly normal, part of life. We don't care about that. What we care about are the non-sampling errors. Non-sampling errors are, I only talk to Republicans. I only talk to short people. I only talk to men. I asked a question that I thought was perfectly understandable, and it wasn't. So some examples of this. Data errors. The first thing you learn in the survey business is that people lie. People assume that there's something going on. You're going to try to sell them something. You have a predisposition toward something, and so you lie to them. One of the classic examples of this was the first time a black man tried to be governor of California, run for governor of California. He'd been mayor of LA, and he was running for governor of California. The pollsters asked two questions. They asked, who are you going to vote for? This man or another man who was running for governor. In that poll, the mayor of LA was 9 points ahead. Then they asked the question, do you think your neighbors are ready to elect a black governor? In that poll, in that question, he was 4 points behind. And when the election happened, he lost by about 4 points. So people don't want to seem like they're bad people. And you take a survey, and sometimes they just flat lie to you to try to make themselves look better or to give you what you want or something. And we have to try to avoid that. And very often, the way to avoid that is to lie to them first. So you ask them a question that makes it sound like, or you talk to them and make it sound like you're asking them about thing A, when really you're asking them about B. And you're happy if they lie about A, if you can get them to tell you the truth about B. So we lie to each other when we do surveys all the time, and we have to figure out who's the better liar. Semantic difficulties, question wording. One of the great errors in this world is when they asked a bunch of people, a stockbroker company, a company on Wall Street, asked a bunch of people in Texas if they owned any stock. Well, stock in Texas includes cows and pigs, and they didn't get a very good answer. They got a bunch of people who told them that they owned cows. So the wording critical. And again, we find out these problems by pilot testing. Then we can do processing or analysis errors. Sometimes people just put the data in the computer wrong. They did the survey, and it ends up wrong in the computer, and then you get the bad thing. And then we have what's called non-response bias. If you send out surveys to 10,000 people in the mail, you're going to get 100 of them back. Maybe 200. You get a bias that's caused by the fact that some people don't respond. In fact, most people don't respond. And it turns out, younger you are, higher your income, there's all kinds of things that stop you from responding. So retirees, if they get a survey, they're much more likely to respond than people who work all day. Little kids are very happy to respond to surveys. So we get some groups that are overrepresented in the response. We might have sent out a nice random sample, but the response we get back is not necessarily going to be random. Okay. All right, so some quick examples here. Nielsen TV ratings. The Nielsen folks put boxes on people's TVs. There's a few other ways they use it. They fill out diaries and they do things, but mostly they get the TV ratings because they have boxes on the TV that are connected back to Nielsen, and so they know who's watching what at all times. And they pick, they have a couple thousand houses around the United States that have randomly selected houses that have these boxes in them. The problem is that the Nielsen families want to be good Nielsen families. So they tend to leave their TVs on even if they're not in the room. So if NCIS is the highest rated television show and it comes on at 8 o'clock on Tuesday, whatever show is on at 9 o'clock on Tuesday is going to have high ratings because some Nielsen families are going to watch NCIS at 8 o'clock and then leave their TV on even though they're not in the room for the next show. Do the networks not know that this is the case? Of course they know this is the case, but they're so used to this system that they don't want to change it. Radio stations get their ratings by people filling out diaries, and there's a million examples of radio stations getting people to bring their diaries in, letting the radio station fill them out, or the radio station paying people to fill out the diaries. Can't trust any of those numbers. A lot of universities do surveys of their freshmen. Turns out that freshmen lie. They want to seem cooler than they are. They want their, past life to seem cooler than they are, and they lie. Casino customers lie. Casino customers, if you survey them about how much money they have with them or, where they go and what they do, they lie. If you ask them how much they spent for their room last night, they lie. If you ask them how long they stayed in town, they lie. Most of the casino numbers we have from surveys are wrong. The casinos know what the real numbers are because they get to see the actual data of what people do in their hotel. But the public release numbers that are from surveys aren't very good because people who come to Las Vegas don't say, hey, I'm staying at the Motel 6 and I'm here overnight and I brought $100 with me. They're always staying at Caesar's Palace and they're staying for a week and they brought $10,000. It's just the way it is. I didn't tell you it was the Girl Scouts, but I already told you about the Girl Scouts survey that we surveyed. And in fact, we surveyed boys and girls because we didn't want the girls to know this was something that only girls did. So we surveyed boys and girls about what they wanted to do after school, and that way nobody knew it was about the Girl Scouts but us. Political polls, same thing. They got to be random. They can't be dial in or call in or, the poll on Fox is never going to be the same as the poll on MSNBC, which is never going to be the same as the poll on CBS or CNN because different people are watching, different people are listening, different people are doing. We do campus climate surveys at UNLV. We try to figure out whether the faculty and staff are happy and sad. And it turns out that, again, lots of people don't answer the survey. It's far more likely that people who are really happy or really sad are going to answer the surveys. A lot of people are just probably aren't going to do it. And so there's all kinds of biases that might exist in those data.